TETRA is another second generation mobile communication system with some similarities to GSM, but also with very different key characteristics. So what is the idea? They are so-called trunked radio systems that can use many different radio carriers on demand. The key idea of trunked radio systems is that you assign a single carrier for a very short period to a user or to a group of users. So for example, using trunked radio systems since many years can manage taxi services, fleets of cars, of trucks or rescue teams. There are different interfaces to public networks, to voice and to data services. But what is quite important for the trunked radio systems always was that they are very, very reliable. They have an extreme fast call setup, so sub-second call setup, and they can operate in a kind of a local fashion without any infrastructure. So that's quite different when you compare this to GSM. So what is special about TETRA? TETRA is also an ETSI standard like GSM. It's a second generation system. It was called Trans-European Trunked Radio because the idea there was the same, to have a kind of a common trunked radio standard across Europe. So now, what is special about TETRA? With TETRA, you can do things you cannot do with GSM. For example, you can have a point-to-point communication and point-to-multipoint even without infrastructure. That's the first thing. That's a big difference to GSM. The second is you really have a strong end-to-end encryption, and not only encryption over the air interface, so end-to-end. Then you can have authentication also of devices, of users and networks. So with GSM, we had authentication of users, not authentication of networks. This is why you can install faked base stations. And we do not really have authentication of devices. So you can use whatever device as long as we have the correct SIM installed. So we have encryption and authentication. What else? TETRA offers group calls, broadcasts, and especially sub-second group call setup. So if you have a commander of a fire brigade, the commander can start a group call, sub-second call setup, and tell everyone, get out of the building, for example. So that's very important. Think of GSM, call setup times, sometimes several seconds, 10 seconds, 15 seconds. Here, sub-second. Additionally, you have a so-called ad hoc mode. It's called direct mode here. So two devices can talk to each other without any infrastructure. That's important, for example, if you do not have a connection to an infrastructure anymore. So then you can still, for example, in a disaster area, talk to each other, exchange data. Devices can act as relays, and additionally, you can have infrastructures. I will give you some more examples for this. Then something extremely important, you have call queuing with preemptive priorities. What does it mean? Again, firefighters, for example, inside a building, they talk to each other, how they should detect the fire, and then suddenly the commander outside detects something. So has to call everyone, has to preempt ongoing calls and tell them get out of the building. This is something you cannot do with GSM. Think of GSM phones. If someone else calls you while you're in a call, you might hear a certain sound, but that's it, and you can ignore it. Here, you cannot ignore it, so the commander can actually preempt anything. And then something else that's very important is a push-to-talk. Push-to-talk is also available. If you want, you can emulate this also with GSM systems using data services. That works. But here, push-to-talk with a very fast reaction time. So that's what you're used to use from walkie-talkies, for example. If you look at the devices, well, you will notice they look a bit different. So for example, what's quite obvious, you see the antennas. Well, also your mobile phone has an antenna, but it's integrated because this is more convenient. But the quality is lower. So if you have an external antenna, then yes, it doesn't look that nice maybe, but you have a much better service quality with the external antennas. Then you have big knobs, turning wheels, whatever. Think of firefighters, they have gloves, for example. And you should be able to operate the devices without looking at them. That's quite important. So for example, if the commander tells you now we go to channel 3, you have to know how to go to channel 3 without looking to the display. So you might turn the knob or to the left and then 3 steps forward or whatever. So that's key ideas. Maybe waterproof devices, shock resistant, etc., etc. So this is a separate world with really extreme requirements when it comes to devices, to the network. So for example, when I say the network should be very reliable, we are talking here about 99.999 and then sometimes some more 9, so 4 nines or 5 9% availability of the network. That means 24 hours, 7 days, 365 days a year. So always. No service interruption. So this is no option. Now think of mobile phone networks. Well, 99.999 reliability. Okay. Well, that's way too expensive. This is why these networks usually have their own infrastructure, uninterrupted power supply, etc. This makes these networks more expensive, but also this makes them more reliable, more robust. So what are the typical areas you use these networks in? Well, there are different sectors, different markets. So these are not billions of terminals, rather millions of terminals. The TETRA system is used in many, many countries, but if you look at the different sectors, you will see, okay, it's something like transportation, a certain percentage, logistics, but then public safety, the government. So police, firefighters, etc. Utilities, gas, water, electricity supplies. Then also defense sector, because it's a really robust encrypted system, a lot of security features. Some other commercial industry, etc. Oil platforms, whatever. They use TETRA. Extremely reliable, extremely robust. Now if we have a look on the network architecture, you will see, oh, okay, that looks, well, similar to a GSM architecture. Okay, not a big surprise. It's also ETSI, so the same standardization body that standardizes here the network architecture. So you see base stations. You see certain switches in between, so like our MSCs, like our base station subsystem. We have air interfaces, that was our UM, and we have our devices, and the devices may have additional connections to whatever peripheral equipment. What is different? That's the DMO, direct mode operation. So that's not possible with a classical GSM phone. So if there's an earthquake and you do not have any infrastructure left, your mobile phone will simply not work. You could think of replacements, doing whatever wireless LAN or things like this, but the classical GSM will not work because you need the infrastructure. These devices will work even without infrastructures, and you can set up your own network even without an additional infrastructure. So that's a big difference. But apart from this, you see switches connected to each other, you see a network management system, you see base stations, that's it. But you can set up these networks also in a kind of an ad hoc fashion. For example, you have a disaster, earthquake or crisis somewhere, or you have a big event like a G7 summit, and then you will be able to set up a network for this purpose to install base stations, all the infrastructure, and then you can handle thousands of users in a relatively small area. And even if one of the base stations is destroyed by lightning, for example, you can replace them directly and the network will not break down. This all happened already, for example, at one of the big summits here in Germany. So these networks will simply work. Depending on the nation, on the regulation, you may have an authority operating the network. So, for example, in Germany, we have an organization, it's called the BDBOS, and they operate the network for police, firefighters, ambulances, whoever uses the network. So the government runs the network, owns the infrastructure, is responsible for the core infrastructure, has redundant operating centers, etc. So how does it work with TETRA? So TETRA offers this direct mode. Apart from the normal operation like a GSM phone, it offers direct modes. And direct modes you can use for individual calls. That's the walkie-talkie, you know, maybe from a childhood. So walkie-talkie mode. But you can also have a so-called dual watch device that communicates with the network, but also in an ad hoc fashion with another device. You can also set up a whole group without any additional infrastructure. That's important for firefighters, for example. You go into a building and you can keep your group together using the devices. So you can talk to each other. And you can also have some kind of a so-called authorizing mobile station. So for example, the commander outside the building can authorize the other devices, can preempt calls, can assign certain groups to certain devices. So you can organize, for example, the attack against a fire. That's extremely important, that you can map some kind of hierarchical command and control structures onto the technology. And also this authorizing mobile station will then control the traffic between a network and the other systems, and you can also authorize the direct mode, so it's a managed direct mode. So that's something you cannot do with the classical UMTS, GSM or whatever phones. So what else can we do? Which is very important, the devices can act as repeaters to increase the transmission range. So repeaters can, for example, build into a police car. So then the police car acts as a repeater between two devices, and two police officers can easily talk to each other. Or, which is quite common on the lower right hand side, you have a so-called authorizing repeater. This is your gateway into the network. Then you have the firefighters somewhere here, and somewhere on a truck you will have the repeater, the much more powerful repeater when it comes to sending power, and this repeater then connects the team with the network. So that's the idea. And then you have some more direct modes with a gateway, direct mode with repeaters and gateways. So you see, you have different usage scenarios with extreme high reliability. So the TETRA system offers you new possibilities, things you need if it's real an extreme situation. A lot of smoke and fire, an earthquake, certain other crisis, emergency, and many different devices. You have to coordinate them, or you have to encrypt everything because there's somewhere an enemy that wants to eavesdrop, etc., etc. So that's a different technology. You can compare it with GSM, but you will find different features, which makes it also more expensive. So what does TETRA offer in terms of services? You have voice and data, voice transmission, data transmission. That's one service called V+D, voice plus data. And you have packet data optimized, PDO. And then additionally something That's like an SMS. Here it's called a short data service. So we have voice transmission. You might think of time slots. Yeah, we'll come back to this. You have packet transmission. More or less something like circuits, packet switching. And you have something like an SMS. It's called short data service. TETRA usually operates on lower frequencies compared to GSM, UMTS, whatever networks. So it operates, let's say, around 400 megahertz, or in some countries around 800 megahertz. So 400 megahertz is quite attractive because you can way better penetrate walls. So you can have still a good reception inside buildings. Furthermore, for larger buildings, it's mandatory to install TETRA repeaters, because then if something happens, the firefighters at least have a repeater in place. So you will find new buildings with several TETRA repeaters. So in case something happens in the basements, then you can still receive the TETRA system. The TETRA itself, it's an FDD, so frequency division duplex, and it uses differential QPSK for the modulation. So many different frequencies, not the same frequencies in all countries. Looking at the TDMA structure of voice and data, you will see, there is also a frame. That's our TDMA frame. Now repeated every 56 something milliseconds with a certain time slot. You see, we do not have that many slots compared, for example, to GSM. Okay, so we have different cell structures, but we also have the idea of multi-frames and hyperframes, certain architectures, certain frame architecture, frame hierarchy. And the time slots, so it is a classical second generation TDMA system using FDD to separate the directions and using time multiplexing for separating different uses. So what can you do with TETRA? The data rates, well, don't laugh, but they are pretty low. So looking back from today's perspective, okay, for time slots, and then depending on the redundancy you need, depending on the interference, you will get something like a maximum of 28 kilobit per second. If you only use a single time slot and you have a lot of interference, it goes down to something like 2.4 kilobit per second. Okay, not really high data rates, but think of that. TETRA was never meant as a high performance multimedia, many pictures download system. It has to be used in emergency situations. Voice is very important, and then maybe some data in addition. But voice is number one. So precise commands in an emergency situation, not surfing the web. So big difference. Okay, but still, the data rates are not high. So maybe, well, as police, you want to transmit a picture of a criminal or something like this. You want to take pictures of license plates for automatic checking, etc. So there are ideas, and that's the TETRA release 2 supporting higher data rates. So TETRA Enhanced Data Service, and that at least goes up to 100 to 500 kilobit per second using different modulation schemes up to 64 QAM. This depends on the interference. So if you really have a lot of interference, if you're somewhere in the basement, a lot of water, fire, smoke and whatever, you cannot go to these modulation schemes. Then you have to use your DQ-PSK, which is more robust. And then it also depends on your spectrum. Do you only have 25 kilohertz or do you have 150 kilohertz? So it depends if you can really have the higher data rates. So that basically is the classical TETRA system. What does the police, firefighters do today? Yes, everyone is used to the high data rates of LTE, for example. And then looking at your private smartphone, and you compare this to your official TETRA phone, you might think, well, okay, it's waterproof, but I also want to have these nice high data rates on my TETRA system. Additionally, the TETRA devices are very expensive compared to the commercial off-the-shelf system. So mobile phones, well, you will get them starting at whatever, 50 euros, 100 euros. You will get them, not the newest smartphone, but at least a mobile phone that can handle LTE and high data rates. So this is why the discussion is ongoing, how to integrate those special features of TETRA into, for example, LTE. So LTE, public safety broadband. So public safety is a general term for these applications, for public safety organizations like firefighters, police, emergency ambulance, etc. And how to integrate now the broadband features of LTE with these special features like sub-second call setup, group calls, high reliability, how to integrate this into the systems. And maybe you will see in the future the integration of these mechanisms from LTE into TETRA systems, but it's very difficult sometimes to integrate these special features into the whole network. So think of a commercial network optimized to make money, and now you integrate these requirements from these public safety networks that are not made for, well, making money, but for the functionality in extreme situations. So it's difficult to integrate these features into today's LTE, for example, networks, and to convince the operators that in case of emergency, the police will need the network and not you, so you will not make any additional money. So it depends on the countries. There are some countries that go more and more towards LTE, integrate special features, and make deals with the network operators that in case of emergency, the police can preempt the other customers and use the network. Some other countries says, no, we need an independent, high reliability network so that in case the commercial network breaks down, we still have an independent network where we control everything, where we have at least something like 6 hours uninterrupted power supply or 24 hours or whatever we think is useful for police, for firefighters. So depending on the situation, well, one or the other decision is the better one. So, and we will see in the future what in the end was the best or a good decision. So there are different ways to go. Some questions. So why do we want to have a separated, specialized system like a TETRA system? That's exactly the discussion. Why don't we use just a normal cellular phone network and add some extras? So think of the reasons for and against such an approach. There are good reasons for both ways of thinking. So if you use LTE, UMTS, GSM systems, what else could be problematic if you use the current systems? Can you use them the way they are? What do you need? If you want to find out, go to 3GPP and check what they do towards public safety. There are special mobile networks. So what is a general trend? Do we see some kind of combination there, two separate networks, or maybe using one as the fallback for the others? So there are different trends you will see.